I'm going to talk about Cubic Motion's contribution to the Present project. Our work is mainly concerned with capturing performance and creating and generating animation for the digital agent. So we developed a stereo head-mounted camera system to capture facial performance and gather the set of face and body training data to use in generative animation tools. This involved quite a lot of work on the face and body animation pipelines and the creation of a lightweight mid-res agent asset. So these approaches were then brought together in the Unreal Engine reference implementation to generate motion for the agent. The locomotion system for the agent was based on motion matching using a training set of dance cards captured for the project. You can see it here applied to the mid-res agent asset and retargeted to the mannequin. Here's an example of the locomotion system integrated with INRIA's UMANS technology, which is calculating trajectories for multiple agents in this corridor test environment. This video shows the first part of the facial animation pipeline.
The patient and the surgeon are both recuperating from a lengthy operation.
So we track the facial contours of the actor in 2D to give us information about key facial features like the inner lips and eyelids over time. And we also use the stereo camera information to reconstruct a depth map of the actor to give us more detailed information for the facial solve. These are then used in the next part of the animation pipeline.
The patient and the surgeon are both recuperating from a lengthy operation.
So this shows the 4D facial solve. So we build a deformable model of the actor's geometry and fit this to the input data. The contours and depth maps act as a constraint to ensure that we get a coherent track of the facial mesh over time.
Hello and welcome to our presentation. I'm Gareth and I'm proud to be both the presenter and the end result of our work over the last 3 years.
We then build a solver to fit the facial rig controls to match the input 4D geometry. So it's important to represent the animation on the character's rig controls because this provides a semantically meaningful representation of the animation for manipulating and blending the emotion of the agent. This result is shown on Framestore's high resolution asset. This example also shows the gaze system, which moves the eyes, head and body to follow the gaze target. This takes into account the speed of movement where the eyes lead the head and the orientation where the body needs to move more to look at a target which is bigger orientation away. These components, along with the ability to move the character around and deliver lines of dialogue, make up the motion generation system, which can be used in a range of use cases as shown by the work of other partners. Finally, I'd just like to acknowledge the people who contributed to this project, as well as thank the other contributors for their work.